This video is part 4 in a series of narrated videos to accompany the A-level chemistry speedrun series of shorts that I've produced. So in these videos I'm just going through the exam questions a bit more slowly and talking through why it is that I've done whatever I've done at each step. This question is a Hess's cycle question from the energetics topic of AS chemistry, and we're trying to work out what the overall energy change for a reaction is. And we're going to do this by drawing a Hess's cycle. So the first thing I'm going to do is to rewrite my equation somewhere near the answer space, because although I have got it in the question, it's probably a long way away and I can't include it as part of my cycle. Now, one of the things that drives me up the wall when I'm teaching energetics is when students start to say, oh, is it combustion or formation? Do the arrows go up or down? And I really hate those systems because they will only work in a certain number of situations. So I say to them, just don't try and learn a rule for it, just think about what's actually happening. So in this table, we've been given formation data. And we know that enthalpies of formation are about the enthalpy change that happens when a compound is formed from its elements. Okay. Now, we don't actually need to specify what those elements are. We're not going to get any extra marks in the exam for talking about the fact that carbon is just on its own or that hydrogen is a diatomic molecule. So I'm literally just going to write a box that says elements. And I'm doing that as a time-saving thing. It's going to take me a while to figure out what those elements are and what their standard states are and things, and you don't get any credit for it. So just don't do it. The next thing I'm going to do is to draw arrows representing each one of these enthalpy changes of formation. So think about what formation is. It's the elements turning into the compounds. So each one of these arrows needs to go from the element box to the compound. So here you can see that I've put 3 times minus 303. And the reason it's 3 times minus 303 is because in my equation I'm making 3 moles. So I need to have 3 times the energy change because I'm making 3 times as much of it. Whereas this one here, I've only got 1 mole, so I'm not going to do any multiplication. And then I'm going to do the same for my other 2 as well. So the whole point of Hess's law is that the energy change for a reaction is independent of the route taken. So I can go the whole wrong way around my Hess's cycle and the energy change will still be exactly the same as if I go from the left side of the equation to the right side of the equation. And I literally do write start and end when I do one of these questions. My year 12s always think I'm a little bit mad. They think I'm being really patronising, but it's a really good way to make sure that actually when you do follow your cycle round, you do follow it in the right direction and you do go from the start to the end and not do it backwards and forfeit 2 out of the 3 marks. So I'm now going to add up each of the enthalpy changes that's represented by one of these arrows, but remembering of course that if I'm going the wrong way up an arrow, then I need to flip the sign or I need to take it away basically. So I'm starting off here with my first arrow, so I'm going the wrong way up it, so I'm doing the negative of minus 303 times 3, because as we said, there's 3 moles, so I need times 3. And then I'm also going the wrong way up the next arrow, so minus 339, but then the final 2 arrows I'm going the right way up. So I'm going to add on my negative 130 times by 3, because again I've got 3 moles, and I'm going to add on my negative 972, and all that lot together comes out to be something like this once I've simplified it. And that gives me an answer of minus 114. Thanks for watching, and if you are finding these useful, then don't forget to like and subscribe for more A-level chemistry videos coming soon.